Now we're going to do section 5.2. And we can start to solve this quadratic function. Solve them. Figure out what x is. Given an equation, x squared equals 16. And we'll start small like that. What does x equal? 4, but it could be negative 4. So it could be 4 or negative 4. And whenever you take the square root of both sides of an equation, we have a plus or minus situation. So it's going to be plus or minus 4. Plus or minus 4. Everything that we do today, we're going to be taking the square root of both sides of an equation. If we have x squared minus 5 equals, I don't know, 18. Okay, let's solve for the variable first. So we add 5. Your directions will say, give an exact answer, and then give answers rounded to the nearest hundredth. Okay? Give an exact answer. Well, let's add 5 to both sides. X squared equals 23. Square root both sides. X would equal what? See, the first things we should be thinking of right now, plus or minus. Okay. Plus or minus what? The square root of 23. And the square root of 23, this is an exact answer. That's exact. Irrational, that means it's a decimal that doesn't end with a repeat. But that's an exact answer. And then the direction said, then, if necessary, if that's not a perfect square, give the answers rounded to the nearest hundredth. That's when you go to your calculator. And it's going to be plus or minus 4.79. What's that third digit? 5. So that would be 4.80. Do we need the 0? Technically, yes, we do. The reason why is because directions say round to the nearest hundredth. So you're telling your reader that you're rounding it to the nearest hundredth. And actually, we should write approximate. Yeah.
Okay, so if in the exact answer, like you would get just a whole number after you did the square root of it, would you still write the whole number after that?
No, you wouldn't need to. Because I think it says round your answer to the nearest hundredth if necessary. So maybe if you get the square root of 25, you don't need to write.
That's all you would put.
That's all you put is plus or minus 5.
Oh.
You don't have to. Okay. All right. So let's take a couple. Let's just expand on this. And one third x squared minus 7 equals 47. Okay. What would be the first thing we'd want to do? You could distribute the 1/3. Ashley, what do you think?
2 times the 1/3 by 47.
Say it again. Times the 1/3, or multiply by? Multiply by 3. I think that's what you meant. Multiply by 3, and that gets rid of that fraction. If you were to distribute, you'd have 1/3 x squared minus 7/3. Then you've got to deal with fractions. But if you get rid of that fraction by multiplying both sides by 3, 3 times 1/3 is 1, and we're just left with x squared minus 7 equals, and then 47 times 3, 141. Okay? Adding 7 to both sides. X squared equals 148. All right, and I'm going to take this up here a little bit. And so x would equal what? Yeah,
Square root of
Uh,
plus or minus.
plus or minus the square root of.
148.
All right, now let's stop there for a second. Plus or minus the square root of 148. Can we simplify that? So you have to think, is there a perfect square factor? What's a perfect square? 4, 9, 16, 25, 49, 64, 36. Okay. So did you discover something in there that's a perfect square root? Okay. All right. That's got to be multiplication. It can't be adding. We can't say 144 plus 4. That won't work. It has to be multiplication, not adding. Yeah. I know 4 is, if you know divisibility rules, because these last 2 digits is divisible by 4, and the whole number is divisible by 4. So let's see. This would be 4 times 37. Is there something that divides into 37 that's a perfect square? No, 37 is a prime number. Square root of 4 is 2. Square root of 4 is 2. 2 square root of 37. Okay, this is an exact answer. If it asks for an answer rounded to the nearest 100th or 10th or whatever it is, then we can put that into your calculator and don't forget the plus or minus. Okay. Everybody with me so far? X minus 3, quantity squared, equals 64. Okay. Do not FOIL this out. Do not FOIL x minus 3 times x minus 3. You're just opening up a can of worms right there. Don't do it. Okay. But what we can do from here is take the square root of both sides of the equation. The square root of x minus 3 quantity squared is simply x minus 3 equals what? Equals plus or minus 8. And don't forget the plus or minus. What we're after here, because there's 2 answers, those 2 answers are where this crosses the x-axis, of where this parabola will cross the x-axis, it's the x-intercepts. So adding 3 to both sides, and we're going to write it this way, 3 plus or minus 8. Then we want to finish this off a little bit, so x is equal to 3 plus 8, and x is equal to 3 minus 8. If you were to graph this parabola, subtracting 64 and making it y equals, these are the 2 spots where it would cross the x-axis, at 11 and negative 5. Okay. All right. The other topic we're going to talk about is right triangles, Pythagorean theorem. The Pythagorean theorem states the sum of the square of the legs of a right triangle is equal to the square of the hypotenuse. These are the legs of the right triangle. Of course, the hypotenuse is the side opposite the right angle. And the formula we generally use is a squared plus b squared equals c squared. The side opposite the right angle is our hypotenuse, and we'll call that c. For the legs of the right triangle, it doesn't really matter which one's A, which one's B. So let's assign numbers to them. Let's say that this is 5 and this is 12. By the way, you can't take the square root of A, B, and C. You can't say A squared plus B squared equals C squared is the same as A plus B equals C. You can't do that. You have this plus sign here. And once you have a sum, then it's not possible to take the square root of each term. Okay, so let's fill in the numbers. 5 squared plus 12 squared equals C squared. 5 squared is 25. 12 squared is 144. 25 plus 40 is 144. The third side would equal what? 13. Plus or minus? No. You can't have a negative distance, right? So in this case, it's not going to be a plus or minus situation because we're talking about a distance. All right? All right, one final problem here. If I can draw this. A baseball diamond, which is actually a square. Who plays softball in here? Anybody? We don't have any softball players? You used to. Do you know the distance from home to first in softball?
It depends on the field. Like the freshman one's different than the junior.
Really? Anybody know the distance in the softball field from home to first? Well, it is 60 feet. Okay. And it's the same distance all the way around. So even though they call it a diamond, it's actually a square. And then we have our right angle there. What we want to know is, how far does the catcher have to throw the ball to get somebody stealing second? What's that distance? What do we have here? Right triangle, right? Okay, so, quick question. Is there any baseball players here? All right. Nathan, you ever hit a home run?
Yeah.
All right. Inside the park home run?
Outside and inside.
Okay. So we're going to assume if you hit an inside the park home run, you've got to run as fast as you can, right? Okay. So if you're running as fast as you can, let's say it's Mr. Shinkonis. He's not a very fast runner, but he's got to run as fast as he can from home to first, first to second, second to third, and third to home. Do you know it's going to take him longer to get from second to third than it will for him to get from home to first, first to second, or third to home? It's going to take longer to get from second to third. You guys knew that, right? You know why that is? Why is that?
A wider turn.
No. It's not because you take a wider turn. When you go between second and third, there's a shortstop in between. See, there's a short stop in between second and third. See, there's a shortstop. You're running real fast, so you have to laugh because we're being recorded here. There's a short stop. You're running and then you stop. And then you continue on.
You should just be a comedian.
Anyway, no, I shouldn't be a comedian because none of that stuff is funny that I say. All right, so it would simply be 60 squared plus 60 squared, okay? And this is a hypotenuse because it's on, this is the only right angle we have. And we'll call that C, I suppose. So I have 3,600 plus 3,600 equals C squared. C squared equals 7,200. And then we take the square root. And that's not a perfect square. 7,200 is not a perfect square, so we're going to have to round it to the nearest hundredth or something, all right? Okay. Your homework for today is going to be on page 286 to 288, 15 through 42 thirds, 44 through 47, and 50 through 58. Okay. And that's it.